Welcome everybody. In today's video, we'll look at the meaning of exponents on any real number. So exponent normally is going to be used when you're doing repeated multiplication of the same number. So let's do it this way. So if n is any positive integer and b is any real number, when we use this notation b to the power n, it is exactly the same as the meaning that you are doing multiplication of b n times. So b times b times b and so on, all together n times. That's the meaning of exponents n here. And b is called the base, and n is called the exponent for your notations. And we look at a couple of examples now. So can you tell me the answer for 2 to the power 3? In this case, it means that you're doing multiplication of 2 3 times, 2 times 2 times 2. It is the same as 8. And then, how about the answer for 0.5 with exponents 2 is the same as 0.5 times 0.5, which is 0.25 here. So the next one, let's try a fraction. How about 4 over 5? Maybe to the power 3, exponent 3 is the same as 4 over 5 times 4 over 5 times 4 over 5. And please do it yourself. It's the same as 64 over 125 here. So let's try one more. If I'm talking about minus 5 to the power 2, it's the same as saying that minus 5, negative 5, or times negative 5. And the two negative signs are cancelled out, so we get 25 back here. So these are the examples you can do yourself. So the next step, we want to talk about a couple of properties of exponents. For example, let's check out this one first. 3 to the power 2 times 3 to the power 3. So can you tell me the answer? So before getting the answer, let's look at it this way. 3 to the power 2 is the same as 3 times 3 times 3 to the power 3 is the same as 3 times 3 times 3. So altogether, you are repeating the multiplication of 3 5 times altogether here. So now it means that in terms of exponent, it's the same as 3 to the power 5. I hope you see what I mean here, because of the repeated multiplication of 5 times of 3 here. So it also means that whenever you have a real number b to the power n is multiplied to the real number b to the power m, you'll get that the exponent is actually the same as the addition of the two exponents here. I hope it is clear from this example, because the exponent here is 2, exponent is 3. Ultimately, we get that exponent is 5. And or to put it the other way, is the same as 3 to the power 2 plus 3. Right? So it's the addition of exponent in that case. So the second property, we can probably look at this example, 2 to the power 2 and the whole thing to the power 4. So there are two exponents here. What does it mean? So let's look at it this way. 2 to the power 2 is the same as 2 times 2. I know that you know the answer of it, which is 4, but let's keep it unchanged, because I want to look at the change of exponents as a total effect here. So now the whole thing bracket to the power 4. So it means that you are actually taking 2 times 2 as a number. We are repeating this pattern 4 times. That's the meaning of this exponent. It means that you can write it down as 2 times 2, the same pattern 4 times, by multiplication. So I hope you get my point here. So altogether, how many copies of 2 can you see here? I think altogether there are 8 copies of 2 here. So it also automatically implies that it's the same as 2 to the power 8. Now, can you notice the change of exponent from here to the n to the power 8 here? I believe some of you can tell me that it's actually the same as the following property here, that whenever you have two exponents and you're doing multiplication in this way, you'll get that it's actually the same as multiplication of opponents. So please don't mix it up with the first properties. They look very different and I'm actually doing exactly different things. So the third property here, let's look at this example. You are doing exponent 4 for the number 3 times 5. I know that 3 times 5 is 15. You can write it down, but again, I want to see the change of exponents related to the base 3 and 5 respectively. So anyway, Let's expand it out. Exponent 4 here means that you're actually repeating the multiplication 3 times 5 4 times. So 3 times 5, 4 copies of them. 3 times 5, 3 times 5, and one more, 3 times 5. So now, all together, how many copies of 3 here are you multiplying? 1, 2, 3, 4. So it basically means that it's the same as saying there are 4 copies of 3, 3 to the power 4 here. Similarly, there are 4 copies of 5. So it means that you can write it down as 5 to the power 4 here. So please notice the change of the exponents from here back to here. So can you tell me the general property of this change? It's exactly the same as the following formula here, that you are basically distributing the same exponent to each base here. So that's why you get that if you write it down separately, you get exponent for both numbers a and b as the base respectively. So that's the third property here. The next one, we can look at this example, 7 over 5 as a fraction to the power 2. If you write it down as 2 copy of 7 over 5 times 7 over 5, again you can redistribute the numbers. Now the denominator is 5 times 5 and numerator is the same as 7 times 7. It also means that there are 2 copies of 7 at the top and the bottom has 2 copies of 5. So I believe you can generalize this property to the following formula. That if you look at the fraction, the whole fraction is to the power n here as the exponent. You can redistribute the exponent to both top and the bottom of the numbers of the fraction respectively to get such a number here. So the next property, we can look at this simple example as illustration. 9 to the exponent 5 over 9 to the exponent 2. So if you expand them out, there are 5 copies at the top of for 9. And then there are 2 copies in the bottom for 9. So now it's a simple factorization fact that you can cancel out the 2 factors. So which means that you are left with only 3 copies of 9 here, which means that the final answer is 9 to the power 3. And please note that it is the same as 9 to the power 5 minus 2. So basically, I'm saying that for division of this with the same base, the change of exponent is the same as subtraction of the exponents here. 5 minus 2, you see? So it means that we have the following formula. That if you look at the division, same base, different exponent, is the same as subtracting the exponent from the top minus the bottom. And now the next one. The next property is that for any number to the exponent 0, the number it must be the same as 1 for any base b here. I don't want to explain too much about it to confuse you, but actually there's a reason behind that. I try to skip it a little bit here just for you to know that whenever the exponent is 0, the number must be 1 regardless of the base. And the next property is about a negative exponent. That whenever you are doing a negative exponent for any base b, is the same as you are writing down a fraction 1 over b to the power n. Again, there's a reason behind that, but I try not to confuse you here. So you just have to memorize yourself that whenever the exponent is negative, have a negative sign, you can write it down as the fraction on the right side here. So to summarize this lecture, we have the following 7 properties. Please review all of them on your own, and in the next video we'll do a couple of examples just to illustrate how to use them effectively to simplify any kind of algebraic expressions. So that's the end of this video. Thank you everybody.